Good morning, all. Today we are going to discuss Kirchhoff's laws. So we know that this is basic laws after Ohm's law. So what is the importance of Kirchhoff laws? So we know that there are two type of laws are there based on voltage and based on current. So based on voltage, we can say it is the Kirchhoff voltage law, and current is Kirchhoff current law. It is found by the Kirchhoff's called as the Kirchhoff laws. And what is the difference between Ohm's law and the Kirchhoff law? Why we go for uh, Kirchhoff law? Obviously, for a complex circuit, we can apply the Ohm's law. That is more than one loop or more than the node, we can apply the Ohm's law to find the voltage or current. That's why we are go for our current law of Kirchhoff and voltage laws. So let's see. Before we have to enter in this session, we have to recall DC components. Conductor, it allows the current flow, and the example is aluminum and copper. And for the resistors, we have it opposes the flow of current. Unit is ohm. We know that, and example of is LED limiting voltages and uh, dividers, and the energy storage also we are using the DC circuit. So inductor stores the energy in the magnetic field, and this unit is Henry. We know that. So conductor, resistor, inductor, and the capacitor is the components of DC circuits. So we are going to discuss in this session what are the topics we have to cover. One is fundamentals and history, and the laws of KCL, KVL, and applications oriented, and the real world applications. So first we have to explore ourselves the Kirchhoff laws. So there are two laws is there. See the diagram, that is Kirchhoff current law and Kirchhoff voltage law. So introduction and the history of these laws are Gustav Kirchhoff found at in the year of 1845. So it's called as the Kirchhoff's laws. So based on the concept of charge and energy, based on the charge and energy, he found these two laws in the year of 1845. So why it is so important that I already discussed, because it is not Ohm's law, it is not applicable for the complex circuits. So um, this is the history of laws. The first you have to see the KCL. So KCL, see the diagram. There are five type of currents. That is five currents I1, I2, I3, I4, I5, I6 are entered in the node or leaving from the node. The current I1 is entered through the node. That is node. We can hear this is in the yellow color. I2 also towards node. I3 outward from the node. I4 is leaving the node, I5 is also leaving the node, I6 enter into the node. So I1 I plus I2 plus IC is equal to I3 plus I4 I5. Or other way we can say I1 plus I2 minus I3 minus I4 minus I5 plus I6, which is equal to 0. So both are equal, that we know that. That is minus terms are cross the equal, then we just make it as the positive. There we can write it in the both equations. So simply we can say that is sum of I in minus sum of I out. So KVL is the statement is stated that the algebraic sum of all potential differences are drop in a closed loop which is equal to 0. Sum of V is equal to 0. Or we can say source voltage is equal to source voltage minus VR1 minus VR is equal to 0, or source voltage is equal to VR1 plus VR2. That is voltage of the resistance and voltage of the resistor V, which is equal to V source, or drop V source minus VR1 minus VR2 is equal to 0. See the diagram. So A plus B plus C plus D E F is equal to 0. Or we can use A is equal to B plus C plus D plus E plus F. We can write like this also. Then it is called as the KVL. And there is the loop directions and rules are there for the direction of current and the direction of battery, the energy, and based on the current flow through resistor, based on the positive supply and negative supply. We can write the energy. We can mention the voltages. That is, here we are considering the resistor A between B, the current flow A to B. The voltage is VB minus VA, which is equal to, so current voltage is VB to VA, but current flow from A to B. Then we can put minus I into R. Here A to B, B minus IB. Then we can put IR. Then here considering the batteries plus and minus, A is connected to uh, negative and V is connected to positive. Then we can write VB minus VA is equal to V. Here VA minus VB, which is equal to minus V. So just you have to keep in all the resistor and the source direction. It will be help us to write the equation in the correct way. If you did any mistake in this while we are writing the equations, mentioning the source or current direction of the IR, definitely the result will be wrong. So just keep in your mind. And Kirchhoff law already we told that what is the empathy of this part is to employ apply the family rules or in the current from the tab is all the empathy of the part. And also the Kirchhoff law components are also used in the principles of physics used to analyze the electrical circuit, and they have no connections of the empathy, right? And these are the application in circuit, applications electronic design, power system, and machine node analysis. And just keep in your mind, um, application of KCL is node voltage, application of KVL is mesh current analysis. And that is a summary of today's session is there are two rules we are discussed, KCL and KVL, in that how to find out the low equations, where how to put minus and plus for the while we are writing the equations for both KVL and KCL. And based on this, we have to what are the rules we have to follow for the current resistor and battery, that is supply source. So all those things we are discussed in this session, and these are the references. If you have any doubt, you have to refer it. And thank you all. See you in the next session.